Using source transformation technique, reduce the given network between terminals A and B into single voltage source. You have to convert into single voltage source with the help of source transformation techniques. So here, how many voltage sources are there? One, two, three, four. All are practical voltage sources because all the voltage sources are having internal resistance. So two parallel voltage sources are connected like this. Two parallel sources are connected like this. This full thing you have to convert it into single voltage source with single resistance. Okay. So in parallel, we cannot add voltages. So we need to convert these two into current source. Again, these two into current sources. So I is equal to V by R. So convert 8 by 2. So arrow mark is towards plus side. So 8 by 2 is 4. 4 amps upwards, and same 2 ohm you have to connect here. 6 by 1 and same 1 ohm you have to connect here. And again here also these two current source voltage source you have to connect. 1 by the 3 by 1 is 3 amps. Arrow mark towards minus to plus. Arrow mark is towards plus here. And 6 by 2 is 3 left side. So this is converted of first current voltage source. This is conversion of second. Now we have to add parallel currents. Okay. So between this node and this node, how many currents are flowing? 4 and 6 both are going upwards. So 6 plus 4 is 10. 2 parallel 1 is 2 parallel 1 is 2 into 1 divided by 2 plus 1. It is 2 by 3 ohms. 2 by 3 ohms. It's 10 amps going upwards. And these two currents, 3 amps going left side. This is also 3 amps. 3 amps plus 3 amps is 6 amps going left side. And again here also 1 and 2 are in parallel between this node and this node. Between this node and this node, 1 and 2 are in parallel. So equivalent distance is 2 into 1 divided by 2 plus 1. It is 2 by 3. Now two currents are in series. This is a current source. This is a current source. Two current sources are in series means we cannot add. So we can add only two voltage sources are in series. So convert this one to voltage source. Convert this one to voltage source. So what is the voltage source value is? So V is equal to IR. 6 into 2 by 3. 6 into 2 by 3 it is 3 ones are 3 twos are 2 twos are 4. It is 4 volts and arrow mark side plus. Arrow mark side plus. Arrow mark is left side. So left side plus. And same 2 by 3 you have to connect in series. Between this and this, there is a current source that we converted into voltage source. Again, between this and this, there is a current source. We need to convert it into voltage source. So between this and this, we have to convert. So 10 into 2.3. 10 into 2.3 is 20 by 3. 20 by 3 and same 2 by 3 you have to connect in series. Now in series we can add the voltages. This is minus to plus. This is plus to minus. So polarity is missed. Which one is greater here? 3 6 are 18. 3 6 are 18. This one is greater. So this polarity you have to retain. This polarity you have to retain plus minus. And from 20 by 3 you have to subtract 4. 20 by 3 subtract 4 means this is a 6.67. 6.67 minus 4 is 2.67. And 2 by 3 plus 2 by 3 is 4 by 3. 2 by 3 by 3 is LCM. Okay, it is 1.333 something it will come. So that is answer. This is next to determine current through 12 ohm resistor using source transformation technique. Current through 12 ohm you have to find using source transformation technique. So this is practical current source. This is practical voltage source. This is ideal current source because there is no resistance parallel across only this. This is practical voltage source. We need to find current through this using source transformation technique. In series, I cannot add voltage source and current source. So I need to convert this. In series, I can add voltage source. In series, I can add voltage source. So I need to convert this one to. I need to convert this one to voltage source. And here current source is there, which is nothing but 48 down. 48. This node is same. 48 is it is similar to 48 is writing from here to here. So it is parallel with voltage source. I cannot add current and voltage in parallel. So I need to convert this one to current source so that I can add currents. So this I'm converting into this current source I'm converting into voltage source. This voltage source I'm transforming into current source. So the value of the voltage source is 30 V is equal to IR. V is equal to IR. I is 30, R is 4, 3 4s are 120 volts, and arrow mark side plus, arrow mark side plus, same 4 ohm you have to connect here. So that now I can add 60 and 30, this I can add voltages are in series. Similarly, I want to reduce this 48 ohms now, so I want to convert this voltage source into current source. V is equal to IR, I is equal to V by R. 240 by 24, it is 10, and arrow mark side towards minus plus. Current is always from minus to plus. Here, arrow mark is towards plus. 10 amps down, and same 24 ohms you have to connect here, and 48 ohms downwards only. Now, in parallel, I can add these two currents, 48 and 10, it is 58. Okay, it is 58, and in series I can add these two voltages, 60, this is plus minus, this is plus minus, so plus minus 120 plus 60 is 180, 120 plus 60 is 180, and this 2 and 4, if you add, you will get 6. Now we have one voltage current, practical current source and practical voltage source. I can in parallel, what I can do, in series I can add voltages, in parallel I can add current. So this is in the parallel circuit. So better you have to convert this into current source so that you can reduce between this and this. You can convert this one into current source. Current value is given by I is equal to V by R. So V is 180 by 6. 180 by 6 is 30 amps. Arrow mark is from minus to plus. And same 6 ohms you have to connect here. And already we have added 10 and 48 as down 58 and 24 volts. Now 24 ohms is in parallel with 6 ohms. 58 downwards, 30 upwards. 58 current is coming down, 30 amps is going up. So net current is, which one is greater? 58. So 58 direction you have to retain. 58 minus 30 is 28 amps. And after that, 6 and 24 are in parallel. 6 and 24, 24 into 6 divided by 24 plus 6. That will give you 4.8 ohms. Now, what is the question? Find current through 12 ohm resistor. Here we have main current 28 amps. Okay, I want to find branch current here. Current through this. By using current division formula, main current into resistance opposite to 12. Resistance opposite to 12 is 4.8 divided by sum of these two, because current is division is taking place between 12 and 4.8. Main current 28 amps, resistance opposite to 12 is 4.8 divided by 12 plus 4.8. So let me do this. You can take this. 28 is the main current. Resistance opposite to this one is 4.8 divided by 12 plus 4.8. You get 8 amps. Okay, if you are using division, then you have to use within a bracket 28 into 4.8. If I use division instead of this box, fraction box, if you are using, I'll show you here, 28 into 4.8. If you are using this, then you have to use whole thing, you have to divide by sum. If you make mistake, you will get wrong answer. You have to use bracket if you are using this. So better use this format. This is the answer.